Hey everybody, my name is Alex Parker. I am a staff product manager here at Replicated, and primarily these days I'm responsible for the installers at Replicated. So that really covers the part of our platform that helps a software vendor install their software at their customer's site. And so really like the stuff that gets installed into the enterprise environment or in order to install a software vendor's application. That's what I'm responsible for. And today I'm going to be talking about what's next for Replicated's installers. So I'll start by talking just real quick about the commercial software distribution lifecycle. This is something that we talk about a lot at Replicated. You'll see this on our website and other materials. But much like the software development lifecycle that you might be familiar with, this is a lifecycle for delivering commercial software to customers. And so this covers the different phases of that lifecycle: developing the application, testing it, licensing it for your customers, releasing it to them, then customers installing that application, reporting back on the health and uptime and different things like that for the application, and then finally supporting the application in customer environments. So for me, install is the main piece that I'm focused on and what I'll be talking about today. And install is all about installing a software vendor's application into their customers' environments. And this is a really core part of that commercial software distribution lifecycle, and it's a really core part of Replicated's platform. Install is one of the most significant challenges that we find software vendors face. If you can't get your software installed into your customers' environments, then a lot of other stuff doesn't really matter. If they don't have it installed, they're not getting the value that they've paid for with it, and you don't need to support it or do these other things if you can't get it installed in the first place. So it's a core part of our platform and core thing that many people come to Replicated for. And for us, it's facilitated by Helm. So we're installing application Helm charts into that environment. And it's often also facilitated by one of Replicated's installers that's being used to deploy Helm charts and possibly other things into that environment. So this gives you a little bit of a look of some of the different installers that we've supported over time. And this is like a spectrum from on the far left, we have the most user control. So this would be for enterprise customers that are very opinionated and they want to be in control of the install and the different pieces and the things that are getting installed in that environment, all the way over to the right side of the screen where it's more turnkey and it's more of an appliance that they're able to install and operate more easily. On that user control side, Helm isn't really a replicated installer. It's really just an open source tool for installing software that many people have consolidated on for installing even third-party applications into enterprise environments. And then moving along from there, we've got COTS, which is our existing cluster installer. So the enterprise controls the infrastructure that they're using, but COTS is automatically deploying the Helm charts and the application into that environment. kURL was our previous generation product for delivering both a Kubernetes cluster and an application into the environment. And then Embedded Cluster took that a step further and combined the cluster and the application into one deliverable that gets installed and upgraded as a single thing. So one install or one upgrade to install both the cluster and the application together. So embedded cluster is what we've been working on the most recently, and it's the piece that I'm going to start by talking about today, but that'll, towards the end, branch off to talk about these other installers as well, and how some of these upcoming changes will affect those installers and people that are using those as well. Like I said, embedded cluster is a way to deliver your application and infrastructure as like a virtual appliance to enterprise Linux machines. So both the cluster and the application getting installed together. There's a intuitive GUI for install and for upgrade and for different ongoing operations. So for less technical people who aren't as comfortable with Kubernetes or don't know anything about Kubernetes even, a lot of the complexity is abstracted away and it's easy for them to just fill out some forms, click some buttons, and just like that, they can install and upgrade and operate even complex software vendors' applications in their environment. The config screen for really easily collecting user input, pre-flight checks to make sure that the environment is ready to receive that application. And then something we've really focused on recently, like in the past maybe year or year and a half or so, has been this 95% install success rate. We have this goal that we've been able to achieve of having at least 19 out of 20 installations occur on their first attempt within 20 or 30 minutes. And we do that through really extensive host pre-flight checks that run before the installation occurs, with really actionable instructions for failures, even for someone who's not technical, giving them really clear instructions on how they can rectify any problems that have been identified so that when they retry, the install is going to succeed. And so I think that if you can achieve 95% install success of your application in less than 20 or 30 minutes, that's really world class for third-party applications being installed in enterprise environments. So what I want to do now is go through a demo of what the next generation of this embedded cluster installer is going to look like. And this will be like a live demo of an early access V3 of embedded cluster that we've been working on. And then as part of that demo, I'll be highlighting some of the changes that we're making. And we'll go from there, talk about upgrade, and also, like I said, talk about how this is going to affect some of the other installers as well. If you're familiar with Enterprise Portal, this is a part of our platform that allows enterprises to come in and manage the life cycle of an application that they've purchased from a software vendor. They can install, get their install instructions, see what instances they have deployed and update those, see information about their license, support bundles that they've generated, and things like this. So I'm going to go to install, and I'll just type in RepliCon here as this instance name. And from here, I'm going to get some instructions on how I can install. So I can choose my version that I want to install. So in this case, I'm going to install my prior version because we'll do an upgrade a little bit later. And then I'm going to copy this first command to download my installation assets. So I'm going to run this. This will just take a couple seconds to download. And this is downloading a tarball that's going to include two things in it. One is a binary. So that's the binary that is going to be used for managing the lifecycle of this application, installing it, upgrading it, things like that. And then the second piece is going to be my license that kind of uniquely identifies me as the customer, and will have my license entitlements and things like that in here. So let me just go ahead and untar this real quick so we can see. So my application is called Harbor Enterprise. So there's my Harbor Enterprise binary and then my license. So I'm going to go ahead and run install, and I'm going to set this environment variable here because this is the V3 functionality that I talked about. This isn't like the normal install yet. So this environment variable is just going to indicate that I'm trying to use this new experience. I'm going to pass it my license and say that I'm installing on a Linux machine. And then I'm just going to say yes to a couple of prompts that come up about self-signed certificates and a newer version being available. So if you're familiar with embedded cluster today, kind of one immediate difference that we're seeing here is that we're getting directed to our browser to start the install. So with embedded cluster today, you're split, and we'll talk about this more in a sec, half between the CLI and half between the browser. So the first change that we're making here is to provide the full install experience from within the GUI. You don't have to do half of the install in the CLI and then later switch over to the GUI. Right from the beginning, you pull up this GUI and you're able to proceed. This is our config page. So if you're familiar with the COTS config page, this is the exact same thing, same config resource that generates it. Couple differences here. One thing is that we've gotten some feedback from customers that the config page can take a long time to render, in particular for configs that are really long, that have a lot of templating and conditional things in them, or generate values on the fly, like certificates and things like that. It can take a really long time for this page to render. So we've sped it up a lot so that even these conditional things happen much faster than they were happening before. So I'm going to provide my user password and then the database password here for my configuration and proceed. This is the setup page. So again, if you're familiar with embedded cluster today, all of this information had to be provided via the CLI because there wasn't a UI available for the cluster installation. So now it's really discoverable that if you've got a proxy server, you need to provide that information. You can change the data directory or some of the ports that get used as part of this install. So we're just pulling all of that into the UI here. And then I'm going to proceed to the installation. So the first thing we're doing is host pre-flight checks. Again, something that happens in embedded cluster, but in the CLI. So now they're a part of this UI, which makes it just a little bit easier to see the failures. They're better presented here in the UI than they are in the CLI. There's also going to be a rerun button in the event that you fail your pre-flight checks. So that's going to make it really easy to just rerun them as opposed to having to quit out of the CLI command, go make changes, and then run install again. So you can see here, I had a failure. I've got a port that is already in use. So I contrived that over here in order to show a failure. So if I stop using port 5000 and then come back here, I can run those pre-flights again, and they should succeed this time around. Another nice thing about having this whole install in the UI now is we can see the whole installation progress, what's coming, what's happening right now, what's already happened. So in the CLI, all of that is just popping up as it comes. Now we can see the different stages of our install. We're also able to retrospectively look back and see previous stages as well as the current stage. We've got progress for each of the steps that's happening. I'll go back to, we'll come back to this in a sec when it's finished because it will take just a little bit of time to run through the install. But I think there's a lot clearer indications of progress here as you're working through the install. And another thing is pulling in installation logs. So we're actually live streaming some of the logs from this install process into the UI here so that you can get a better sense of what's happening, how are things progressing. If something does go wrong, you don't necessarily have to go down to the CLI to troubleshoot things. You can find that right here and rectify those issues a lot faster. So we'll revisit that in just a second as it finishes, but let's go through again and recap some of the improvements that we're seeing here on the install side of things. So first is that complete UI experience. So now we've got the full install occurring in the UI. This is what it looks like in embedded cluster today, where a good 50% or more of the install happens in the CLI. And then eventually the admin console is ready and you're able to go visit that and proceed with the install. But this really left you with kind of this disjointed process of half here, half there. So this really unifies the UI or the install into a single process that happens here. And then it's going to be easy to see the host pre-flight failures and rerun them after you fix issues like I demonstrated a second ago. Another benefit here is going to be the improved deployment visibility. So I showed logs being streamed live into that UI, making it a lot easier to troubleshoot things if anything goes wrong, or just to get a sense of how the progress is going. Better progress indicators across the board, so just clear what things have happened and are yet to happen, which steps we're at, and even for the whole install process, what's left, what's happening now, etc. And one thing that is going to be a big difference is showing each application Helm chart as it's deployed. For example, in this hypothetical WordPress application, there's 3 Helm charts that make up this application. Today in COTS or embedded cluster, when you do a deploy, you just see that it's deploying and you don't get a sense of how many things are a part of this deployment, which ones have succeeded and which ones have failed. So we're going to get a lot more granular here and give you a lot more insight into what charts are we deploying, which ones have succeeded, which ones have failed, which ones are in progress. And it's going to really help zone in and narrow down what's left. If something goes wrong, troubleshooting is going to become a lot easier because it's going to be clear that it's this chart and the problem's going to be manifested here on this page, things like that. And another thing that is going to be significant is a lot less proprietary install logic through this process. So when we look at that install flow here, we're really just installing Helm charts. But if you're familiar with the inner workings of COTS and embedded cluster today, there's a lot of complex version rendering that's happening. There's things that get injected. There's additional things and manipulation of the Helm charts in some cases. We're storing a lot of stuff in an object store or a database in order to keep track of the versions and redeploy them and stuff like that. But if we store things in cluster or on the host, they're much easier to access, much easier for you to see and understand. And like I said, at the end of the day, we're just installing Helm charts. So we're cutting out a lot of really complex logic that had bogged down this install process and effectively just turning it into, if you were running a Helm install for this application, what would you run? And that's exactly what this installer is going to do instead of a lot of proprietary stuff that it had started to do today. So let's go back here to the UI and see where we're at. So we're still installing the admin console here. So we still got a couple of steps left here. We'll keep going onto the upgrades, and then we can come back and show a demonstration of those as well. Let's see. So before we demonstrate them, let's talk about some of the improvements that we're going to see on the upgrade side of things as well. So the first is going to be integration with Enterprise Portal. So we saw during install how we went to that Enterprise Portal and we got our install instructions and we were able to follow those in order to install this application successfully. With Embedded Cluster today, the install works that way, but the upgrade all happens from inside of the admin console in the environment. So you end up with a different process for install and a different process for upgrade. And if you come to Enterprise Portal to upgrade, it doesn't really give you any helpful instructions. It just says go to the admin console to check for updates and to upgrade, because that's how the process works. But now we're actually pulling the upgrade process more into Enterprise Portal. And that's going to have a lot of benefits. First of all, it's going to continue to make Enterprise Portal the go-to place for your customers to engage with your application, with new releases, with support, with all of those sorts of things. So if they want to know if there's newly available versions, it's not they're going to a different place to do that. They're going to come back to the Enterprise Portal, both to install and to find out about those new versions. It also lets them get email updates when new versions are available. So all of these functions of Enterprise Portal become available as we continue to integrate the embedded cluster upgrade process into Enterprise Portal. And then you also end up with a lot of similarities between the install and the upgrade process. Today with embedded cluster install and upgrade are very different because one is happening largely in the CLI, and then one is happening by checking for updates in the admin console and deploying those. Whereas here, install and upgrade, you're coming to the Enterprise Portal. It's very straightforward and easy for people to always know whatever you want to do, come to Enterprise Portal, and that's going to be your hub for all of those things. Another improvement we're making is the improving the resilience of these upgrades. So in the embedded cluster today, the upgrade process and the UI run as a pod in the cluster, which has a couple of downsides we'll talk about. But with this new installer that this V3 version here, all of that's going to run from a binary on the host instead of being a pod in the cluster. So when it's running as a pod in the cluster, any downtime to the cluster, like if a node is being upgraded, for example, is going to result in some downtime for the admin console. And so by running this UI and this upgrade process outside of the cluster, we separate it from the upgrade of the cluster. And so you don't lose connection to that UI halfway through the upgrade like you do today in embedded cluster. It also means that we can run host preflights for upgrades to catch issues beforehand. So we run those host preflights on install because we're running the install process from a binary on the host. That's much more difficult to do on upgrade if that upgrade happens from within a pod in the cluster. So by taking the upgrade process and putting it on the host, it opens up the ability for us to continue to perform those preflight checks and make sure that an upgrade is going to be successful before it starts. So let's head back over here and see that we have installed successfully. So we can look back through the different phases here. And then when we're finished, installation complete. If you had any links to your application, this is where those would show up. So now let's talk about upgrade. So from here, I'll exit out of this because our install is complete. And I had installed version 1.2.0. I downloaded it. I'm going to download 1.2.0 instead of 1.1.0. So this is my newest available version, and I'm going to download this tarball just like I did for the first one. We'll untar it a second, and then we'll run the upgrade. And what you'll find here is that the upgrade process is going to be nearly identical to the install process. Both the UI as well as the steps that you're going to go through and the things that are performed are all going to be almost identical to install because it's all the same stuff that's happening. So we'll untar this to get our newest version. And when this is done, I'll just run the version command real quick in order to show that this is, in fact, version 1.2.0. Now I'm going to make sure I set my environment variable, set upgrade, and pass my license. This is what I get for doing a live demo. So it takes just a second for COTS to actually recognize that the first version has been installed. So that'll come up in just a second. I'll be able to run the install. So I'll come back here and start talking about what's happening next beyond this. So we've talked about the embedded cluster use case and how this new installer is improving and transforming that. But I also want to touch on some of our other installers and how this has the potential to affect those as well. So this isn't supposed to be just an improvement for embedded cluster. We really want this to lay the groundwork for improvements to all of our different experiences, including kURL and COTS and Helm. So starting with kURL, this is our kind of first generation embedded cluster product that a lot of our customers are still using today. And we're currently working on in-place upgrades from kURL to embedded cluster. So this is going to provide an easy way for users who are on kURL to upgrade to embedded cluster. They're just going to go through a normal embedded cluster upgrade experience, much like what I'll try to demo in just a sec. But it's actually going to detect that there's a kURL installation present. It's going to export some necessary information, stop the kURL instance, deploy embedded cluster, recreate the PVCs and migrate the data. And then there will also be hooks available at various stages for people to customize that upgrade process as necessary. So the goal here is for this to really feel like an upgrade and not like a significant migration. All of this is going to be automated so that your customers will be able to just run an upgrade and get onto this newest version of embedded cluster and get to experience all of the benefits there. For COTS, we are considering support for upgrading COTS installs to this new installer as well. So the idea here would be that we have that same V3 UI and user experience that I just demoed, but instead of installing k0s and the other infrastructure pieces that get installed as part of embedded cluster, we would just install the application into an existing Kubernetes cluster that we have kubectl access to. So this would work very similar to COTS, but instead of having COTS as like an operator deployed inside of the cluster, managing things and requiring a pretty high level of RBAC and things like that, this installer works completely client-side and just installs the user's application and their components into the cluster, which I think helps to minimize objections and issues that enterprises have when they see additional dependencies and components that could have vulnerabilities, need a lot of permissions. It takes those things out, and it's really just your application that's getting deployed here. And then finally, Helm. With Helm, application Helm charts are installed directly with the Helm CLI. So there's not really a replicated installer that's involved here. But something we've found in our experience, but I'm sure anyone that's familiar with Helm would agree with this, Helm values can be really hard to use. It's just a YAML file where you're editing a bunch of values. Hopefully you don't have any typos. Hopefully you make all the right changes in the right places. There's not the easiest ways to have dependencies between values and make sure things are set correctly. But if you're a replicated customer, you've put all this time into creating a config page for your COTS and kURL and embedded cluster installs that makes it way easier to get all of that input and map it to the correct Helm values for you. So what if you were able to use both? So the idea here is that you'd be able to give a customer this binary. They could run a configure command that would show the config page. They would fill out all of their information here. And at the end, instead of installing something, they would click save, and it would actually write out all of the necessary Helm values to a file on their computer. So that now they can go run a Helm install, but they know that they've got good Helm values that are validated and have the right information in them. So you can be sure that even though you've got a lot of control with that Helm install, you can be sure that Helm install is going to succeed. So ultimately, this kind of brings all of these different use cases into one installer or one binary that supports different use cases and different install types. I think this has the ability to really streamline documentation and support and onboarding for a lot of our customers, where they've had to get used to different products, different UIs, and different experiences depending on how they or their customers were installing. And by bringing that all together into a more singular experience, you've got one tool that you have to document with just different ways of installing with that tool. One tool to train your people on, to learn how to support and things like that. So I think all of that is going to make it a lot easier. Now I'm going to come back over here real quick. Hopefully that's had enough time for the install to fully succeed and this upgrade here can take effect. Yes, cool. So I ran upgrade. And you'll see, just like before, it's just telling me to go to this link in the UI. So I'm going to go ahead and do that. And you'll see it looks very similar to install, but now I'm going to upgrade. And we don't have to spend too much time on this. We'll wrap up right here. But basically, I have a chance to change my config if there's any inputs I want to change. And then I go straight into this upgrade process, which is going to look very similar to the install process, but of course is going to upgrade all of these components to the right versions. So that's about it. I'm happy to answer any questions that anybody has. But if not, thanks a lot. And feel free to get in touch if this is something that's interesting to you, or if you've got any more questions in the future. I'm always happy to touch base and would love to hear from you.
There's one question in the chat.
Ah, excellent.
Yeah, I see that. Yeah, so it would be a zero downtime upgrade. Some of that can depend on how your application is architected and ensure that your application is going to work that way. But yeah, there's not downtime in the upgrade of our components, for example, and there shouldn't be in yours either.